Okay, so moving on to even and odd functions. Okay, so these are going to seem, the tests for these are going to seem very, very similar to the symmetry test, but it's just a little bit different. So let's first talk about what an even and odd function are. So a function that's even is symmetric with respect to the y-axis, and a function that's odd is symmetric with respect to the origin. Okay, so it is really, really similar to the symmetry test, and the algebraic check for these is we just replace x with negative x. So we find what f of negative x is, and if it is even, then you'll get the same function as the original. And if it is odd, when you replace x with negative x, you'll get the function, the negative version of the function. Okay, so the test is the same. We replace x with negative x, but if it's even, you'll get the same function as in the beginning, and if it's odd, you'll get the negative version of that. Okay, so let's look at some examples here. Number 7. Okay, determine algebraically if the function is even, odd, or neither. If even or odd, describe the symmetry. So again, we're looking for f of negative x. Then we get negative x cubed minus negative x. Negative x cubed is just going to be negative x cubed. And then minus negative x is going to be plus x. So we compare this to the original, and we find that this is opposite. So this is equal to the negative version of the whole function. So if we were to multiply the entire thing by -1, then we would get this resulting equation here. So we say that this is odd, and it has a symmetry, it's symmetric about the origin, or with respect to the origin. Okay, number 8, same thing, we find f of negative x, and here we get negative x in parentheses squared plus 6. This is negative x squared plus 6, so this negative comes from here. This negative goes away because we're squaring it. And we see that this is neither the, this is exactly the same as the original equation, so we say that this is even. And this is symmetric about the y-axis. All right, so f of negative x is equal to negative x in parentheses cubed minus negative x squared minus 2 times negative x. We'll simplify this here. This is negative x cubed minus, so remember we're going to do the exponent before we subtract. So this will end up being positive x minus just x squared, and then plus 2x. So this is neither the original equation, nor is it the opposite version. If this was a positive, then it would be, if that was a plus sign, then it would be opposite, but because it's not, it is neither. It is not none. There's no symmetry, and we say it's neither even nor odd. Number 10 here, f of negative x is equal to the square root of negative x squared minus 4. That's equal to the square root of x squared minus 4, which is the same as the original equation. So we say this is even and symmetric about the y-axis. Number 11 here, f of negative x is equal to negative 8 over negative x, which is equal to 8 over x, which is opposite of this, because we can always pull this negative, the 8 out front, so it's negative 8 over x, and now we have positive 8 over x, so this is odd. And it's symmetric with respect to origin or about the origin. Either way you say it means the same thing. And last one here, number 12, f of negative x is equal to the absolute value of negative x plus 1, which is not the original. And because we have a binomial here, we have two terms, we can't actually take the absolute value of this and find what that is. So this is neither even nor odd. And that is even and odd functions.